Welcome back. This is the video 2 of the chi-square lecture. So we just talked about the chi-square test of association. That's using two variables. The chi-square goodness of fit is only using one variable that we are comparing to some kind of a standard. So this is really important when we are looking at trying to see if certain data fit a model or an expectation that we have. So we collect data on one variable and we compare this to some specified or legislated or goal or some expectation that we have for that data. For example, do the proportion of tomatoes with certain characteristics match the genes of the parents? So we have an expectation of what the genes of the parents are, and then we compare the actual genes that we're seeing. Or do the proportion of Red Rocks campus students by gender reflect the proportions of the state of Colorado or of the US? So we can compare our campus, our data, and how many gender differences we have, and then compare that to the state or to the United States and see, is it similar? Or we can see if our goal for international students, if we have a goal of 10% international students at Red Rocks, have we reached our goal? So we can look at how many international students we have compared to the rest of the population, and did we meet that goal or come close? Or business, this happens all the time. So do people eat at our restaurant evenly throughout the day? Really, is that probably your expectation? Probably not. You know there's going to be busy times. So you could say, do people eat at the busy times that we expect? So you could calculate how many people are eating between 11 and 12, 12 and 1, 1 and 2, and then compare your expectations for what those would be and see if it is meeting your expectation. Computation, that looks really familiar. So the sum of whatever's behind it, which is the frequency observed minus frequency expected squared divided by frequency observed. And then the sum of all of those, exact same. What is different is this expected value. So in this case, it's going to be the proportion or percentage in each category or in each cell times the total n. So what was the goal? What was the expectation for that category, for that group? Degrees freedom is also different because we will only have one row. So instead, it's really columns minus 1. So here's our example. If Red Rocks has a goal of 35% minority students, and we have the current student population of white and minority, we want to see, did they meet their goals? So we can have a goal of 35%, but seriously, nobody's going to be exactly at 35%. So what we want to do is see if what the actual amounts are close enough to the 35% to not be significantly different from this group. Here's how we're going to do it. Number 1, make a table. So we have 1370 students that are minority. We have 3630 that are majority. And I just added those two up, so I have my total. Now we have to figure out these expected values. So if the goal of Red Rocks administration was 35% minority students, we're going to figure out what is 35% of 5,000. We have our expected value for minority students. And the majority goal, in that case by default, is 65%. Of 5,000 is 3,250. So I'm going to add in those expected values right here compared to our observed. So we can see that these values are different, but we want to know, are they different enough that we can consider that we didn't meet our expectation? Or are they similar enough that we can say we met our expectation? So we're going to take again our observed minus expected squared divided by expected for cell 1. 82 is a very large number, isn't it? And then we're going to take the next cell, so our observed minus expected, squared divided by expected, and we get 43.31. Also a very large number. That means that our chi-square is adding these two numbers together. That is a massive number. Do you think it's significant? Well, let's find our degrees freedom. In this case, we only have one row. So it's columns, the number of columns is 2 minus 1. We're going to look that up on Google by typing in chi-square to p-value. That's going to give us a calculator. Our p-value is less than 0.001. That means Red Rocks did not meet their goal. There are less minority students than expected, and there are more white students than expected. Again, to get this expected and not expected, we go back up to these guys. Anything that's above a 2, so these are way different than expected. Anything above a 2 means that cell is unexpected. So take a minute and review. What are the two types of chi-squares and when do you use each one? What are the steps? How is goodness if it different? And what do we include in write-ups? Pause. Make sure you know these.